Multiplying and dividing rationals. So you factor the numerators and denominators of both expressions if possible. Identify the non-permissible values. Once again, it's just the denominators that you state non-permissible values for, but now you have two denominators that you state non-permissible values for. And you have two numerators and two denominators that you have to factor or GCF or difference of squares them. Okay? So it's just the same thing as simplifying, you just now have an extra one. Okay? So we're going to do the same steps. So simplify the following rational expressions and state non-permissible values. So we're going to look at the top left, x plus 1. Can I take anything out of it? Any GCFs? Is it difference of squares? No, it's just x plus 1. So we go equals, because this expression equals the next expression equals the next, so you have equal signs. X plus 1 in brackets. I put it in brackets because it's attached together, right? They're sewn together with that plus sign. So you're going to put brackets around them. Then underneath you have x plus 3. Can I reduce that in any way? No. Now instead of a multiplication sign with an x, we use a dot, a closed dot, because then you don't get it mixed up with variables, right? 2x plus 6, is there anything I can do to that? Take out a GCF of 2. 2x divided by 2 is x, plus 6 divided by 2 is 3. So the x plus 3 goes into its own brackets, and so does the 2, because it's multiplied by it. The denominator, the bottom of the right-hand rational, what could I do to it? Take out an x, GCF again. And then you're left with x plus, x divided by x is 1. Do I have to write that 1? Yes, it's very important. Because when you divide something by itself, you actually are left with a plus 1, not 0, right? So you have to put plus 1. Now I know some people get excited and they're like, yay, x plus 1s can cancel. Before you get excited about that, you have to state non-permissible values of any denominator, correct? So in our denominators right now, we have x plus 3 can't equal 0. We have x can't equal 0. And we have x plus 1 can't equal 0. Because those are the three factors that are in our denominators. And we always have to state what our denominator can't equal 0. So x plus 3, I just subtract the 3. And I get x can't equal negative 3. X can't equal 0. And subtract 1, x can't equal negative 1. So my NPVs are x can't equal negative 3, negative 1, and 0. Now, once I stated non-permissible values, I can actually cancel off anything that matches. So on the top left, if it matches on the numerator anywhere or the denominator anywhere, you can cancel them off, even if it's across the multiplication symbol. Because multiplication really means this times this times this over denominator times denominator times denominator, right? So you could either put them together all first and then cancel them, or you could cancel them and then put them together. It doesn't matter. They'll get you the same answer. I'm going to cancel them off first. So what's the same in the denominator and the numerator? X plus 1. Now I can only do 1 for 1. So if I had an x plus 1 in this denominator and an x plus 1 in the right denominator, I could still only cross 1 off for 1. So it was a 1 for 1 deal. Okay? Now, what else could I cancel off? Could I take this? If this wasn't an x plus 3, say this was an x plus 2, could I cross the x's off? No. X plus 3 only is going away if there's an x plus 3 to match, and there is. Then in the numerator, I'm left with a 2, and in the denominator, I'm left with an x. Can I cancel any of that off? No. So I'm left with 2 over x. X cannot equal negative 3, negative 1, and 0. So if you can simplify, this is not hard, right? It's the same thing. It just has 2 rationals now instead of 1. So I want you to try B and C, and then we're going to go through them. So try B and C. So for B, in the numerator on the left, I can't take out anything. But 12 is multiplied by, I'm going to put equal sign. 12 is multiplied by the x cubed, so I'm going to put them in brackets. The denominator on the left, I can take out a 3 and an x. 3x squared divided by 3x is just x, plus 6x divided by 3x, which is 2. And then that 3 and that x are multiplied, right? So you can put them in their own brackets. The top right, what could I take out? A 4x squared.